You know that familiar knot in your stomach right before pushing code to production? Yeah, we've all been there. So, welcome to this explainer. Today, we're diving straight into the modern end-to-end Azure development lifecycle. We're going to break down exactly how to move your code from your local machine all the way to the cloud, seamlessly. Whether you're a seasoned DevOps engineer or a developer just trying to smooth out your day-to-day workflow, getting this pipeline dialed in is absolutely critical for modern software delivery. Let's get right into it. This quote right here perfectly captures the core tension we deal with every single day. I mean, teams are under relentless pressure to ship new features at absolute lightning speed, right? But, and here's the kicker, you have to pull that off without breaking things for the end user. Shipping fast? That's great, but shipping fast with rock-solid quality? Now that is the actual goal we're chasing. To solve that tension, we're basically going to walk through the ultimate software assembly line. We'll start with your local Azure dev environment, move into securing your GitHub workflows, then dive into automating quality in CI/CD, and finally, we'll wrap up with the modern release workflow. All right, part one, your Azure dev environment, building the foundation locally. Let's look at how this all starts right on your laptop. Setting up your IDE for Azure is honestly a total breeze. It just takes 3 simple steps to give yourself a really powerful control center. If you're using Visual Studio Code, and it doesn't matter if you're writing in .NET, Python, or whipping up front-end apps, you just download the editor, grab the Azure Tools extension pack from the marketplace, and sign in. Boom. Just like that, you've completely bridged the gap, instantly connecting your local environment directly to your cloud subscription. No complex configuration required whatsoever. And with that extension pack installed, you basically get a dedicated control panel right inside your workspace. Without ever having to leave your editor, you can spin up and manage your app services, your serverless functions, storage accounts, Cosmos DB databases, and virtual machines. It's fantastic because it totally eliminates that annoying friction of constantly context switching back and forth between your code and a web browser. Now, if you really want to supercharge this setup, you've got to leverage AI with GitHub Copilot for Azure. It acts as an intelligent assistant sitting right there in your editor. Think of it kind of like having a senior engineer constantly looking over your shoulder, in a good way. Instead of desperately hunting through endless documentation or trying to memorize complex CLI commands, you can just use plain natural language. You can ask it questions about your resources, troubleshoot tricky deployment issues, or figure out exactly how to configure a highly specific service. Moving right along to part 2, securing your GitHub workflows. Let's talk about moving from your laptop to the cloud securely, because once our code actually leaves our machine, things need to be locked down. So, the real question here is, how do we securely connect GitHub to Azure? You have to figure out how to basically lock the front door to your cloud environment when you're connecting from automated GitHub actions. When your CI/CD pipeline needs to push that fresh code to Azure, well, it obviously needs permission to do so. And managing those permissions securely, that's a massive priority to keep unauthorized access completely out of the picture. Let's quickly compare our authentication options here. You could use traditional Azure secrets, which means you're manually creating a client secret and then storing it in your repository settings. But as we know, those permanent secrets require super careful handling so nothing gets leaked. On the flip side, we have OIDC, or OpenID Connect. This is definitely the more modern approach. It relies on temporary, identity-based access. That means you aren't storing permanent credentials in GitHub at all. I like to think of it this way. Using secrets is kind of like handing someone a physical master key to your house, whereas OIDC, that's more like giving them a digital hotel key card that just instantly expires the second they check out. But hey, if you do decide to go the traditional secret route, there are 4 specific values you'll need to grab from your Microsoft Entra Service Principal. You'll need your client ID, the client secret, your subscription ID, and your directory or tenant ID. Once you've got those, you package them all up into a single JSON format and save it securely as a repository secret. Most folks just name it Azure_credentials. Okay, so once those credentials are safe and sound, what next? Well, you simply drop the Azure login action, specifically version 2, right into your GitHub YAML workflow. That action basically consumes the secret credential package we just talked about, securely authenticates your runner, and grants access. From there, all your subsequent Azure CLI or PowerShell deployment scripts are perfectly safe to run. All right, part 3, automating quality in CI/CD. This is where speed meets rock-solid stability. Pushing code securely is awesome, but we really need to make sure the code actually works when it gets there. Let's trace this continuous testing journey inside Azure DevOps. The very second code is committed, it kicks off the build pipeline. This is where your unit tests jump in to verify individual components, and those test results are published immediately. Then, moving into the release pipeline, things expand. You've got broader integration and UI tests simulating real-world user actions. And finally, you run those post-deployment validations just to be absolutely 100% certain that everything is stable before the final production release. Now, to keep this entire assembly line moving fast without hitting annoying bottlenecks, you've got to adopt some high-impact strategies. Shifting left is huge here, meaning you're catching bugs early in the cycle when they're much, much cheaper to fix. Then there's parallel execution, which lets you run massive test suites simultaneously across multiple agents. Oh, and you absolutely must keep your test data stable to avoid those frustrating false failures. Finally, bringing in AI-powered self-healing tests, that is a total game changer. It means minor UI changes won't constantly break your scripts. And let's be real, nobody wants to spend their Friday afternoon updating 50 scripts just because a button changed from blue to green. To keep all of this organized, Azure Test Plans acts as your central command center. And it is incredibly powerful because it directly links all of those automated pipeline tests right back to your user stories or requirements. It basically gives you this beautifully unified view to track pass and fail trends, seamlessly combining your manual exploratory testing with those automated regression checks. That way, literally nothing falls through the cracks. Which brings us to our final section, Part 4, the modern release workflow. Let's look at supercharging this pipeline with ExcelQ to really take things to the next level. Integrating an AI-powered platform like ExcelQ with Azure DevOps is where the real magic happens. It unlocks no-code test creation. This means your business analysts and QA leads can build incredibly robust tests without writing a single line of script. It also gives you true cross-layer coverage, so it's validating the UI, the API, and the backend, all at the same time. Plus, because of its native pipeline integration, all your reporting is totally unified right alongside your standard Azure DevOps metrics. The best part? Setting this up is crazy simple, just 4 steps. You install the ExcelQ Azure DevOps plugin, connect to your workspace, map your test suites to your specific pipeline stages, and set them to trigger on commits. Do that, and suddenly, your pipeline is automatically firing off comprehensive AI-powered tests on every single code change. It perfectly bridges that gap between insane development speed and true enterprise-grade quality. Just as the ExcelQ documentation points out, shipping fast is really only half the battle. Speed is actually pretty dangerous without quality. But with this integrated pipeline, you never have to compromise or choose between the two. When you combine the security of those GitHub workflows with Azure's rock-solid hosting and advanced continuous testing, you are creating an environment where rapid deployment is actually reliable. So after seeing how securely and seamlessly the modern Azure code-to-cloud lifecycle can actually run, I really have to ask you, is your current CI/CD pipeline up to the task? I mean, is it a high-speed highway or is it a massive bottleneck? Take a hard look at your own setup this week and ask yourself where you can start shifting left and automating those quality gates. Thanks so much for joining me on this explainer, and I will catch you in the next one.